Hello, hello, my dears. We have made it to the last week of this crazy distance learning math business. So hopefully you have learned something, but we're going to finish up with just talking about a couple more features of the unit circle and some trig ratios. So you have talked about sine, cosine, and tangent pretty extensively. We know sine is opposite. It's a ratio of opposite over hypotenuse. Cosine is a ratio of adjacent over hypotenuse. And tangent is a ratio of opposite over adjacent. Again, opposite and adjacent relating to whatever angle you're talking about. But there are three other ratios we need to consider. Because this is a ratio, if we were to flip it, we would have a new, different ratio. And so 1 over sine, or the inverse, this flipped, so hypotenuse over opposite, is going to be called cosecant. And then secant is going to be 1 over cosine, and then cotangent is going to be 1 over tangent. So these are all inverses, and notice they all have a co. So sine goes with cosecant. Cosine goes with secant. Tangent goes with cotangent. So that's a way to keep that straight in your brain, because tangent and cotangent should sound pretty similar. They both have that tangent sound. And then the opposite to the others, sine has to have a co, so it goes with cosecant. Cosine already has a co, so it goes with secant. Hopefully that makes sense. All right. So let's just look at these, what it means when we're actually solving. So if we're given sine of pi over 3, first we need to look and find out where pi over 3 is. This is radians, so it's a little less familiar to most of us. But pi over 3 is equal to 60 degrees. So we're looking right here, and we want to know what the sine is. Well, if we were to draw our little right triangle right in here, right? We draw a right triangle here. And we're looking at this angle. Sine is opposite over adjacent, and the opposite over hypotenuse rather, and the hypotenuse is just 1. And the opposite is that long leg there, so that's going to be the square root of 3 over 2. So sine of pi over 3 is square root 3 over 2. Cosine is going to be adjacent, so that's the short leg, 1/2. Tangent is going to be opposite over adjacent, so we're going to do square root 3 over 2 divided by 1/2. Invert and multiply. Our 2's cancel out, and we're left with just the square root of 3. Did I do that right, or did I do that? Let's see. Opposite over adjacent. Yeah. Okay. So then we're going to invert and multiply, and we get square root 3. Okay. Cosecant. So we said that cosecant is the inverse of sine. So we're going to take what we got at sine and we're going to flip it. So that'll be 2 over the square root of 3. But you're not allowed to have the square root of 3 in the denominator, so we're going to multiply by 1, square root 3 over square root 3. And we end up with 2 root 3 over 3 as our final value of cosecant. Secant is going to be cosine flipped, so we're going to do 2 over 1. 2 over 1, which is just 2. Cotangent is going to be tangent flipped. So we have square root of 3. So then we're just going to get 1 over the square root of 3, which we know is not allowed. So we have to multiply by 1 again. Square root 3 over square root 3. Whoop. And we end up with root 3 over 3 as our cotangent value. All right. Given sine of 225, see what you can do with those measurements there. Check the video for your answers and make sure they are correct. The last thing I want to talk about with you guys is what a sine wave looks like and why, now that we understand the unit circle a little better. So remember, when we're talking about sine, we're talking about those opposite values or our vertical values. So they end up being our y values, right? When we look at our coordinate ordered pairs here, we are looking at y values when we talk about sine. So if I went to graph this on just an xy chart and I'm graphing my values here at 0, I'm at 0, right? My y value is 0 at 0. Okay, when I go over to pi over 2, so my x-axis here is just being measured in radians. So when I go to pi over 2, I'm looking right here now. When I go to pi over 2, what is my y value? Now I'm up to 1. So now I'm up at positive 1 over here. Okay, when I go to pi, now I'm back to 0. So I'm just graphing this based on my y values. And then when I go to 3 pi over 2, I'm at -1. That's down here, right? And then at 2 pi, I'm back to 0. So what you end up having is this wave because of the fact, and this just continues on, same thing if we were to go backward around the unit circle, and obviously that wave should go lower, whoop, and actually match, but this is going to be a wave that follows a very specific pattern based on the pattern that you see in the unit circle. So we go up and then down, and then as we go around, we're getting this wave this way. Sorry, that was a little confusing. Okay, let's do cosine and see if this makes sense. All right, so now we're talking about our x values, right? We're talking about our adjacent values here. So when we think about our adjacent side, we're thinking about our x values. So when we think about this in our ordered pair, we're looking at our x values here. So at 0, we're actually starting at 1 for cosine. And then when we get to pi over 2, which is 90 degrees, now we're at 0. And then when we go to pi, we're at -1. Again, notice this pattern is going to look very familiar. We just kind of started in a different spot. So now my wave looks like that. Notice we start at 1 here with cosine, and with sine, we start at 0. But these waves should look pretty similar to each other. Again, my poor drawing here, but the waves should look pretty similar. They just are going to layer on top of each other a little bit differently. So if you see, they're just kind of starting from a different spot, but the wave should look pretty much identical. So that's a basic look at your sine and cosine waves and where they come from. Hopefully that makes sense. And then just a quick look at tangent here. I already graphed it for you. But because we have in tangent, we have a relationship of opposite. Oops, let's do orange. We have a relationship of opposite over adjacent. So if you think about at this point here, we have a 0, right? So opposite over adjacent, opposite is going to be 0. I'm not going up at all. Adjacent would be 1. All right, that's fine. No problem. We can divide 0 by 1. That's just 0. But what happens when we get up here? Well, now I have my opposite is 1, and my adjacent is 0, and I am not allowed to divide by 0. So right here, I would be dividing by 0. I would get 1 over 0. Well, that's undefined, so we get an asymptote, because we know that values that are undefined, when we go to graph them, we get an asymptote for those. So we end up with asymptotes every single time we try and divide by 0. So every single time that we have an x value of 0, we're going to end up with an asymptote. So that's just a quick look at these graphs. You'll do a lot more with this next year, but I wanted you to at least see where these waves come from, why they exist, and start to pay attention to those patterns. Hopefully all this makes sense. Miss you guys tons, and good luck with your final next week.